Hello Creativerse, this video I'm going to be showing you the difference between the ripple carry adder and the look-ahead carry adder. The look-ahead carry adder is the one that I'm implementing on the ALU. The ripple carry adder is the simpler version. It uses way less logic gates and is way simpler. The difference is that in the look-ahead carry adder, each bit will calculate its previous carry. It doesn't need that the previous carry finishes to calculate its output before calculating the carry. On the ripple carry adder, it will calculate the first one, then the carry will come to the second one, so you will have to wait until these 7 are finished its calculation before you can be sure that the last one is correct. This is needed for the same way if you are adding on decimal. You are adding, let's say, 4 numbers in decimal, and this one right here is just 3 and 4. You cannot say that the result is going to be 7, because if the previous one generates a carry, then the result is not going to be 7, it's going to be 8. But let's say the previous one is just 4 and 5. You cannot be sure that this is going to be 7 and you're not going to have a carry, because if there's a previous carry, 4 plus 5 plus 1 is going to be 10 and you're going to have a carry coming in. And the same way will be with this one. You cannot be sure if this one is going to have a carry or not until you calculate this one, and so on. So that's why on the ripple carry adder, which is the normal version of doing it, you will calculate the first one, then you see if you have a carry, you pass it to the second one, you calculate the second one, and that way until you are done to the next one. So this is generally slow on a computer because you have to make many cycles. But let's see here. Okay, and besides that, the ripple carry adder uses way less gates, as I said that, and it's extremely simple. On these logic gates, I have to add a lot of extra gates. Really, the look-ahead carry adder just uses these 5 gates. This extra 5 gates is just 5 gates that I have on my ALU, so I have to add them here just to make them even. What will happen is that I have a gate to check if I have the add, 2 OR gates to compare the outputs with the and the OR, and 2 extra OR gates that do for the shifter. So basically it's just adding 5 extra gates that the output has to pass through, so I can put it at the same ground that the ALU that has to pass through a lot of extra gates before it generates this one right here. So what I'm going to do, I have it on 0, both inputs are enabled, and the inverters are 0 and the increment is 0. I'm going to start generating carries first from this one all the way to the end, and see at what point does the look-ahead carry adder becomes faster. So let's start from this one. So you see the ripple carry was way faster, that one. Now this one. Still way faster. Let's go to 4. Wait, I made a mess. Slightly faster. Go to 3. So now the look-ahead carry adder becomes slightly faster at 3. So it has generating the carry at bit 3, and it has to propagate it through 1, 2, 3, 4. On the 4th one, then is that it becomes faster. For now on, the look-ahead carry adder is going to start becoming faster and faster. Well, the ripple carry becomes slower. The look-ahead is the same speed. Because what happens is that for the look-ahead carry adder is quite constant, the speed, but the more you have to pass through these bits, through these adders, the look-ahead carry adder is going to start becoming slower and slower. this is the extreme case when you have, when you're going, I'm gonna do an increment here and it's gonna pass through all the bits until it gets to the last one. So yeah, the look-ahead carrier is significantly faster. Now, really, if you take all these gates and you take all the gates from the all the extra from the look-ahead carrier, it really makes not much difference on the speed for just 8 bits. So it's really, and this one uses 5 gates per bit, so it's just gonna be 40 for the whole 8 bits, while the look-ahead carrier is on the 100. I don't even remember how many, but 100 something. So yeah, it's really, I don't know, if you think that it's worth it, go for it. This one is way simpler. I'm gonna stay with the look-ahead carrier one because I already have it done, and second one because I care more for the worst possible scenario than the average speed, because I have to give it a time for the ALU to finish, and it cannot be less than the worst case scenario, because otherwise at some point I'm going to get a wrong output. Okay, so now let's get to how this one works. What I'm going to do to show you how this one works is I'm going to do one myself. So let's go down there. It will be a lot better. I was looking for a place to do it, so I think this is a good place for it. First I'm going to put 3 switches. These are going to be 1. These are going to be input, let's say B and A, and this is going to be the carry. So carry AB. First I'm going to get 2 gates, and this is going to be the exclusive words. So I'm going to have, let's put it right there. The exclusive ORs are going to give me the sum, the actual sum for that input. Then later we're going to calculate the carry. So the output, this one's going to come to here, this one's going to get the carry, and these 2 are going to get the inputs. When you have 2 exclusive ORs like this, or you have exclusive ORs and you start connecting inputs, the result is going to be that the last exclusive OR is going to be true when this is odd, and it's going to be false when this is even. So let's see how this works for the sum. The sum of 0 plus 0 plus 0 is going to be 0, and this is 0. So when you have 1, the sum of 1 plus 0 plus 0 is going to be 1. You have the 1 there. So when you have 2, it's going to be 1 plus 1, which is 2, which is even. So the result of this is going to be 0, because we're not calculating the total output, we're just calculating the output for that 1 bit. 2 is 1, 0, so the actual sum that we're calculating is 0. It's just going to have a carry coming into the next one, but we're not calculating the carry right now. We're just calculating that sum. So then if we have another one, it's going to be 1, because 1 plus 1 plus 1 is 3, and 3 is 1, 1, so we will have a 1 with a carry of 1, and we're not calculating the carry just yet, so it's just going to be 1. Now let's do the, well, it really doesn't matter the order. If I have 2, either if that one or this one is going to be 0, or if I have 2 like this is still going to be 0. If I have 1, it really doesn't matter either, it's going to be 1, whether it's whichever one, it's just always going to be 1. If I have an odd number here, it's going to be 1. If I have an even number, it's going to be 0. So let's do the carry now. The carry you're going to do it with AND gates. First, you get the two inputs through an AND gate. If the two inputs are 1, it will mean that it's 1 plus 1, so you have a carry. Even if this one, it doesn't really even matter anymore if this one is a 0 or a 1. If you have a 1 and a 1 here, you're going to have a carry. So I'm going to get this one as an OR gate. And this one is going to come in this one. So yeah, if I have a 1 and a 1, a 1 and a 1, it's going to be 2. So the other situation that you're going to have is you have to take into account the carry. So this gate right here is going to be 1 if one of this is 1 and the other one is 0. So I have a 1 and a 0, this is going to be 1. And if you have a 1 here plus a 1 from the carry, you're going to get a carry. So let's see an example. That's a 1, so this one right here is true. Consider this is true. So we have this one connected. If I put this one to true, this AND gate will be between this exclusive OR gate, which is being true, and the carry, which is being true. So this one will be true. So basically, this is how all of them are done. This part right here, the two exclusive OR, they calculate the sum. The two AND gates calculate the carry, and I just need an OR gate to connect the two AND gates. So then basically what will happen is that you see how we have this switch right here that we're working as a carry, and it's being connected to those two gates right there. When you have a next one, let's say that when you have a next of this, what you're gonna do is that this output right here, you're going to connect it to the same place where these two are connected. So the carry coming out of this bit is going to be connected to the next bit, and the carry connecting of the other bit is going to be to the next one, and to the next one, and to the next one. All the bits say one after the other. And this sum is just going to go to whatever output that you want to do. In this case, I'm just using these two LEDs. And yeah, that's how this adder works. If you want to know more, you can just look it up for the adders. This is a full adder, a ripple look ahead carry adder. I'm just gonna take this one out. And we're gonna head straight to the look ahead carrier. And now my inventory is full. I'll take care of that later. So let's start with this one. First I have, this is the output for A and the output for B. This part right here is very familiar with what you will know already from the carry adder. This is an exclusive OR gate, and this is an exclusive OR gate, and it works the same way. It's connected one to the carry and to the two inputs, so it's identical. This AND right here is just here for the ALU, so I can just add whenever I want to, not all the time, and that's it. So this part is the sum, which is identical to the one on the carry adder. That's why it's easy to transition from one to the other, because the actual addition part is identical. The one that you have to change is the logic for the carry. So on here we have two gates. One is going to be true when you have propagating, and the other one is going to be true when it's generating. I named them as G0 for generate from 0 and P0 from propagate. So basically it's going to be an OR. The propagate is going to be an OR, So if you have a 1, it will mean that it will propagate the signal. If you have a 1 and you have a carry coming in, let me go there. This is gonna be easier to explain on the. Okay, so we have the property is an OR. So if this one is coming in, and let's suppose you have a carry coming into this one, it will be 1 plus 1, which will be 2, which will generate a carry. So having a 1 will mean that it will propagate it. So let's say right now all of these one are propagating the carry. So it will mean that if we generate the carry right here, the carry is generated with an AND, meaning that you have 2 1s. If you had generated with an AND, then it will come here, this will be 0, and it will pass a carry as 1. This one will be a 0 and will be pass a carry as 1. Let's just say for simplicity, this one generates it, then this propagates the carry, this one propagates the carry, propagates the carry, propagates the carry, propagates the carry, propagates the carry. That's it. This one gets the carry and doesn't propagates anything or generates anything. So the propagation, you get it with an OR gate, and the generation you get it with an AND gate. Let's go back there. So yeah, and that's how these two signals are generated, and they are needed for the look ahead carry logic. We're here on bit 1. The only way on bit 0, the only way you get a carry is through the increment, which is the switch that we have on top. That's the only way you can get a carry at bit 0, because there's no addition that has happened beforehand. But on bit 1, there's one addition that happened beforehand. So you actually have two ways of getting a carry here on bit 1. One will be that you get the increment and that bit 0 propagates the carry. The second way will be that bit 0 generates the carry. And this is how it's going to be done to every single one. Let's say each subsequent bit has an additional option. So the first one is always going to be the increment, but on bit 2 it no longer needs to be propagated just by bit 0, because bit 1 also needs to be propagating the signal. So the first option will be that you get the increment, bit 0 propagates the signal, bit 1 propagates the signal. The second option will be that bit 0 generates the signal and bit 1 propagates the signal. And the third option will be that bit 1 generates the signal. And this is going to be adding extras unless it goes to the last one. So I'm not going to go through every single one, but let's have fun with this one a little bit. So this one is when the increment, but we're on bit 7, so it has to be propagated by 0, it has to be propagated by 1, by 2, by 3, by 4, by 5, and by 6. All these are just to get the logic all the way through. But it basically, it gets generated by the increment and it's propagated through the whole ALU. They said this one will be when G2 is generated at G2 and bit 3 propagates it, bit 4 propagates it, bit 5 propagates it, all the way to bit 6 propagates it. Then it will reach bit 7. So they all have to be propagated by bit 6. So this is generated by 4, propagated by 5, propagated by 6. This is generated by 5, propagated by 6. And the last one is just when it's generated by 6. That doesn't have to be propagated by any, because it's generated on the bit before bit 7. So it doesn't need to be generated. And this is the idea of how the look ahead carry adder works. You basically have to have an option, and you have an option for each previous bit of how the carry can be generated. One will go to increment, then will be generated at bit 0, generated at bit 1, generated at bit 2, generated at bit 3, generated at bit 4, generated at bit 5, and generated at bit 6 right here. And of course it has to be propagated through the whole ALU, so if you have if you do it through the, let's say, bit 0, it has to be propagated in bit 1 and bit 2, bit 1, bit 2, bit 3, bit 4, bit 5, all the way. So if you see the switches, it's going to be easier to visualize how this works. Basically, if you generate bit 1, bit 2 has to propagate it, or it's not going to go to bit 7 unless all of these are propagating. So that's why it has to be AND gates, because all of them have to propagate it for this to be true. And these are basically options, so all of these are just OR gates to get all the options. And that's it. The output comes here, and it comes as a carry. And this is how the lookalike carry adder works, if it makes any sense. Well, thanks for watching. If anything, just leave me a question. Thank you. Bye.